today's tutoring session, I had to tutor an 11th grader for the subject pre-calculus, math. And I asked the student which topic exactly is it that they were currently focusing on. And the student told me that it was the Pythagorean Theorem. So what I did is I introduced them to a little bit of the history about it. And that is the fact that over 2,000 years ago, there was an amazing discovery about triangles. And also a fun fact is that when a triangle has a right angle, that's, when the triangle has the right angle, it's 90 degrees. And squares are made on each of the three sides. So this is kind of how it would look like if they were conjuncted together, if they were connected together. Also, the biggest square has the exact same area as the other two squares put together. So it is called Pythagorean Theorem, and it can be written in one short equation, which is a very important equation, a must know, and that would be a square plus b square equals c square. And it's important to know that c is the longest side of the triangle. A and b are the other two sides. In definition, the longest side of the triangle is called the hypotenuse. So the formal definition is that in the right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So I said, sure, let's see if it really works using an example. So I gave this example to the student. Example A. So we have 3, 4, 5, and it's a triangle. It has a right angle in it. So as we know, right angles, as mentioned previously, are 90 degrees. So I said, let's check if the areas are the same. So what we're going to do is we're going to insert the numbers where the letters would be. So a squared plus b squared equals c squared. So in this case, a squared would be 3 squared, b squared would be 4 squared, and c squared would be 5 squared. So 3 squared plus 4 squared equals 5 squared. And luckily for me, the student knew what to do. So the student knew that they had to multiply. So that would be multiplying the squares. So 3 times 3, right, equals 9. And 4 times 4 equals 16. And 5 times 5 equals 25. So when calculating, it becomes 9 plus 16 equals 25. And there you go. And then I said, how is this useful? So if we know the lengths of two sides of a right angle triangle, we can find the length of the third side. But remember, I said, it only works on the right angle triangles. So I said, how do we use it? So this was a problem that I allowed the student to work by themselves with. So I said, write this down as an equation. So we have this triangle, right? And as we know, the formula equation is a squared plus b squared equals c squared. So we're going to use algebra to find any missing value. So let's use this example. So let's solve this triangle, I said start with, of course, the equation, which is a squared plus b squared equals c squared. Then we're going to insert the numbers where the letters would be, right? So put in what we know, which is 5 squared plus 12 squared equals c squared. So let's calculate squares, shall we? So as we know, multiply, right? So I said, let's see. 5 times 5 is 25. 12 times 2 is 144 equals c squared. So let's calculate, keep calculating. So 25 plus 144 equals 169. So 169 equals c squared. So let's swap sides. C squared equals 169. So square root of both sides. C equals 169. And the square root of 169 would be 13. So it would be C equals 13. And why is it 13? Because 13 times 13 is 169. And then For the rest of the tutoring session, I just kept giving them examples to work on. And the student was very smart, quick learner. Luckily for me, it was fun. And yeah, that's pretty much it.